So count vectorizer will either create a document term, by default, it will create document term matrix. Okay, and we need to convert the words into matrix of numbers. That is what we have to do. You have to convert the words into matrix of numbers. If you don't do that, you can't do any analysis. So in online guys, any doubts? Okay. So So for count vectorizer, we have to give max features based on the max features or number of variables or columns. You have to give max features based on the number of rows you have. We have 12,000 rows. I am giving up to 300. 300 into 50, how much? 15,000. We can't give 15,000 because we don't have 12,000. We have only 12,000. So I'm giving up to 200 variables. 200 into 50, 10,000 something. So that's what I'm giving. Now, min df is also very important here. Min underscore df means how many, what you call, you can eliminate the words. That means we want words that appeared in more than 2 sentences or documents. So it's a method of reducing the words. Min underscore df means you will consider only that many words that appeared in that many documents. So you can say, like here, I given min df is equal to 2. That means you will have only those words that appeared minimum in 2 documents. Minimum in 2 documents. Similarly, if you want to further shorten your corpus, you can see here the document words will change based on the minimum number of appearances in the document. It is getting changed because these words have appeared in more than 5 documents. The one which is there, see, disease, COVID, pandemic, diseases, cases, viral, acute, these are the words that appear more than 5 sentences. So that is why these words are not changing. Okay. So basically what we are getting here is these words already appear in more than 5 documents, 200 features, 5 sentences. In our case, it is sentences. Or let us say min df is equal to 0.25, 25% of the documents. Then we will see any shape. Oh, we got an error. After pruning, no terms remain. 25%, nothing. Let us say 10%. Still nothing. See? Try a lower min diff or a higher max diff. 10% means how much? 120 documents. So min diff 10. So min diff 10 also we are getting a good. So min diff is a way of reducing the number of words. Another important thing you can give here is n-gram range 2,2. Gram range is not working. You can also give n-gram underscore range. It is, you have to 2 by 2 means bigrams. Bigrams means 2 words. Now we have only one word, right? In our words, we have only one word. Bigram, if you give, it will be 2 words. Bigrams means 2 words. It will no longer be one word, it will be 2 words. Similarly, we have sometimes we use trigrams. Trigrams means 3 words. Unigram is 1 word. What we are using is unigram. Unigram means 1 word. So basically, sometimes in some situations, we have to use bigrams and trigrams also. That means the number of words. Here we are using unigram, which is one word. So we also have this range of words that can be used. You can also use stop words here.
Sir,
Yes, please.
in this vectorize, we are converting the words into matrix form.
Yes, like this. Word and sentences. In sentence one, how many times the word has come? Word one has come in sentence one. Our data is sentences, right?
Yes, sir.
Because we have already removed, na? Let me see if n-gram range ones. Bigram words are not coming. Bigram is not there. Okay, all of you are done till this point. Can I move forward? That is A and they will be removed. We already removed them. Otherwise, you can remove them here also. If you have forgotten to remove in the top, when you are vectorizing it, you can remove them. Okay, can we move on? Count vectorizer. Yesterday we have discussed what is the count vectorizer of converting of words to numbers. Matrix. It's a matrix format. Words on the what you call column. Oh, sorry, rows. And the here the words to word matrix has been formed. We have formed only word to word matrix. Because we have broken the words into what you call turned into the words, right? So we have created a word to word matrix here. Three words, two words. So here we have used only one word. So let me show it that one more time. See, we have sentences, right? Sentences df dot head is a cleaned one. We have cleaned the sentences, right? We have cleaned the sentences and then we've broken them into words, right? So basically, what we have done is we have tokenized the words and then we removed the stop words and we have taken the words greater than 2, right? Then we have done that. Now you can also run count vectorizer on this because in real life you will be running count vectorizer on the sentences also. Now I'll show you how to run count vectorizer on sentences. Now we have already imported count vectorizer, right? We have already imported count vectorizer. So max features is 200 words, stop words English, minimum underscore df is equal to 5. We have defined a vectorizer. We have defined a vectorizer, right? Before that, we will do one thing. Sentence has to be converted to lower, because we are capital words also, right? Okay. Sentences, yes, yes.
Why do we need to convert them into lowercase?
Because all, that is one of the thing in text mining, all the words must be in lowercase.
Okay.
Oh, what an error. Numpy array object has no value lower. Dot lower. Oh. So dot str dot lower. Okay. So sentences df dot sentence is equal to sentences df dot sentence dot str dot lower. Now, if I run the sentences df do head, now you can see all of them have converted to small letters. All of them have been converted to smaller letters, right? So basically, once we have done the sentiments and we have converted them into lower and we remove the stop words. Here also, we will do the same thing. Sentences df, we have converted the sentences to lower. And then we have defined a vectorizer. Now we can give range also here. X1 is equal to vectorizer dot fit underscore transform sentences df dot sentence x1 dot shape. See, we got only 980 words, 156 features. So we got too many features. So we will make the features to, we have only 980 sentences, right, in our data. So how many features we can give? 15, 15 or 16. Okay, 16 features we have created. Now, what features we have created, to see that, we will do this. Now you can see two words. Earlier it was one word, right? SARS-CoV, coronavirus disease, health organization, meta-analysis, disease control, control prevention, systematic review, world health. 2 words, bigrams. We have created bigrams. Earlier, we have created unigrams. Unigrams means single word. Bigrams means 2 words. Trigrams means 3 words. Generally, we don't go beyond trigrams. And mostly used is bigrams or unigrams. Here you can see the headers, 2 words. And if you see the top header, here you will see only one word. Got it? This is called unigram. Whereas I have used bigram here. I have used bigram here. And all the words are relevant, right? To COVID-19. All the words. This you need to remember, because in data, what you have is, you have a column called reviews. You have a column called description. That will be complete text. Sentences will be in one column. And you also have ratings, feedback, what you call average rating, price, budget, movies data. The whole story will also be there in one single cell. Story can be 500 words. So when you have such thing, you have to use this format. You have to convert sentences into words. Yesterday, we are converting the document term matrix from words only. Word to word matrix we were creating yesterday. Here, today we are creating from sentence to words. 980 sentences. So if you look at these sequence number, 975th sentence has corona disease, has the word health organization, had the words centers and disease, both the words are there. You can see the numbers, two words are there in 975th sentences. Now this is sentence term matrix. What we are seeing here is sentences. We got 980 sentences. Sentence is on rows, words are in columns. This is your sentence term matrix or document term matrix, which is created by count vectors. Now, this is the format you will be using on real-time data science. Customer reviews analysis, feedback reviews analysis, or if you're doing medical descriptions analysis, disease description and all, you will be using this model. Right? Yeah. All right. We have how many sentences we had? Yesterday, how many sentences we had? 990 only, no? Then that's all. So your number of sentences will be 98 only, right? 0 to 979. It starts from 0. This is your sentiment-wise words. Sentiment-wise, sentence-wise words. Now you can add sentiment to this model and you can do machine learning. You can add a dependent variable called sentiment, and now you can use this matrix to do machine learning. To predict the sentiment. Based on the words, you can predict the sentiment. We already calculated sentiment, right? 980 sentences sentiment we have. Make it as dependent variable, add it as y. We have 980 matrix. Now we can do machine learning, you can do logistic regression, decision tree, random forest, anything to build a model that predicts the sentiments based on words. Right, now it becomes a machine learning problem. Right.
Before we had this math feature, there's one.
So because that time we had a words corpus of 12,000.
Let's say I was 200 only for now. And then I print the state. So would the word like just keep repeating for?
No. It will take only the maximum. So you will get only 150 words or something, not 200. That just print the shape. You will get only 150 around, because there are not that many words available here. So there are not many words available here. So we can create count vectorizer from sentences also. Sorry, document term matrix from sentences also. So like this is what you will do.
So the 16 like bigram versus have that like most repeating ones or
most frequent ones. Okay, so this is how we will do, and then you can now build any machine learning model by adding sentiment as dependent variable y. by adding sentiment as dependent variable, you can do a multinomial classification because we have three sentiments: positive, neutral, and negative. Got it? This is one type of vectorization. We are converting the words to numbers. Until unless you convert the words to numbers, you cannot do any sort of data analysis. When the data is in words, all you can do is frequency analysis. Right? Conversion of data into words. Now, one of the most important thing you need to use is online guys. Any doubts? No, starts from here only. Start sentences df dot head. You can start from here only. We'll apply. We'll do that also. But let us complete the pre-processing, then we will do the ML. Because you need to understand one more vectorizer. One other important thing you need to understand is term frequency inverse document frequency, also called as TF-IDF vectorizer. TF-IDF vectorizer. The TF-IDF matrix uses probability calculations and creates matrix. So in count vectorizer, we are just counting the words. It's only count. Whereas in TF-IDF, we have a specific formula. From sklearn dot feature underscore extraction dot text import TF-IDF vectorizer. This is a very important vectorizer which is used in real-time data science. TF-IDF vectorizer. Now the formula is so this is the formula for TF-IDF. This is the formula for TF-IDF. Term frequency into log of number of documents or number of sentences divided by number of documents containing the word or term. Okay. Now, let us see what is this thing. Let us say I have sentence A. The car is driven on road. The car is driven on road. We have sentence B. The truck is driven on highway. The truck is driven on highway. So we have two sentences. So if you remove stop words, post stop words removal, what we have in sentence A, we have car driven on and road. On is also important, no? B is truck driven. On is also a stop word. Okay, we'll make it on as a stop word. Okay, no problem. Highway. Driven and highway. Now, let us calculate TF-IDF for the term car. I want to calculate the TF-IDF for the word car. So first, what we have to calculate? Term frequency. Of car is equal to, how many times it is coming? 1 divided by 3. Total number of words is 3. 0.33. Inverse document frequency. Inverse document frequency is log of, how many documents, how many sentences we have? 2. N is 2, right? N is total number of documents. 2 divided by, now number of documents containing X. How many documents has the term car? 1. Log 2 by 1 or log of 2. What is the value for log of 2? NP dot log 2. 0.6931. 0.6931. Right? Now, TF IDF of car. Multiplication, right? Car, which is 0.33 into 0.6931 is equal to, how much you will get?
Sir,
Yes.
can you once explain what is inverse document frequency?
Inverse document frequency, the formula is log of N by DF. Log of N by DF. N is number of documents, total number of documents or total number of sentences. How many total number of sentences we have? 2. DF. DF is number of documents containing the term. How many sentences or document is containing the word car? 1. So log of 2 by 1. Log of 2 by 1 is log 2. Log 2 is 0.6931. Multiply 0.33 into 0.6931. You will get 0.2287 as TF IDF of the word car. Got it?
Yes, sir.
Yeah. First, you need to calculate TF and then you have to calculate IDF. IDF is log divided multiplied by log of n by DF. Log of n by DF. Try calculating TF IDF for the word driven. For driven. TF IDF for the word driven. TF IDF for the word driven. Term frequency of the word driven is 1 by 3. It is coming in two documents, right? 1 by 3 into 1 by 3, which is, how much is 1 by 3 into 1 by 3? Because it is coming in two documents, right? Is equal to 1 by 9. 1 by 9 is equal to how much? 1 divided by 3 into 1 divided by 3. 0.111, right? Now IDF, inverse document frequency for the word driven, which is log of how many sentences are there? 2. How many sentences it is coming? 2, which is log of 1. What is log of 1? 0. Log of 1 is 0. So TF IDF of driven is 0.111 into 0, it will be 0. So if the word is coming in multiple documents, it will be assigned a value of 0. Thereby it eliminates words. If the word is coming in all the documents, if the word is common in all the documents, it automatically eliminates that word. So we will not get ones or zeros here. You will get a decimal values in TF IDF vectorizer. In interviews, they'll ask you. In NLP interviews, this is one of the most important question. term frequency, inverse document frequency. What is the formula calculating what you get? We get the probability values. And it is different from count vectorizer. In count vectorizer, we'll simply count the words, one, whether it is there, 1 or 0. Here, it's a probability based calculation. It's a probability based calculation. And in real-time data science, TF-IDF vectorizer has a better performance than count vectorizer, slightly better.
Like TF-IDF of given is 0, right? What does it mean?
That means the word will not come in the matrix itself. The words will be eliminated. So TF-IDF has a method of eliminating. It will take only the unique words. And it will give less weightage to the most frequent words. See, if the word is coming in most documents, it gets less weightage. Automatically, TF-IDF value will be less, right? When the TF-IDF value will be less, in an ML algorithm, it will be given less weightage. The bias will come into picture, right? So if it is coming less frequently, it has a higher probability value. If it is coming more frequently, the probability value will decrease. Got it? The method of calculating TF-IDF vectorizer. This is the other vectorizer. Apart from count vectorizer, see, count vectorizer will simply create a matrix of document term matrix or term document matrix, which is simply count of the values. Here it is a probability based calculation. From sklearn dot feature extraction dot text import TF-IDF vectorizer. TF-IDF is equal to TF-IDF vectorizer, open bracket, stop words is equal to English, comma, max underscore features is equal to 16, comma. So whatever we have given in count vectorizer, we'll give the same argument here. Min underscore DF is 5. Min underscore DF is equal to 5. N-gram range is equal to 2, comma 2. X underscore TF IDF is equal to TF IDF dot fit underscore transform sentences DF dot sentence. Min-diff you can give minimum is 1 document.
Constantly TF-IDF got vocabulary.
Oh. Similar one. Okay, so we have just converted, we have created an independent variables matrix. See, this whole purpose of vectorizer is to create X. What is X? Independent variables matrix. From text to independent variables. Because we have to have independent variables, right? Without independent variables, you cannot do any machine learning or anything. We had a simple text. We have simple text in the form of sentences. Now, using the vectorizer, we have converted those sentences into matrix of words. Sentences are converted into words. A matrix with numbers. Now, when you have a matrix with numbers, that is your independent variable matrix is there, X is there. You can simply have to add Y and do machine learning. If you don't want to add Y, you can keep X as it is, do unsupervised learning like K-means clustering. You have clustering methods, right? You can employ clustering methods, K-means clustering. You don't need a dependent variable for doing clustering analysis. You simply have to have numerical variables in the data. That's all. If you want to do a machine learning algorithm, you need to have a dependent variable. The dependent variable here can be sentiment. We have 980 sentences sentiment. So we will use the X to predict the Y. That can also be done. Or if you can do unsupervised, you can continue with unsupervised learning and do clustering. K-means clustering, hierarchical clustering. You can do any clustering analysis. For clustering, you don't need to have dependent variable. Clustering is an unsupervised learning algorithm, right? So you don't need to have a dependent variable. Whereas machine learning is supervised learning. In supervised, no. So, okay, I'll show you an example. Okay, where is the data? Okay, it's in Google Drive. This is a very large data. Yeah. Okay. See, this is a US Medicare data. In the United States, Medicare data is, medical is free for its citizens. Okay. We have downloaded the data here. So this is the medical data. Now, where we have the provider who provided the service, okay, place of service, how many providers are there, services, amount, lot of procedure cost and all are there. Payment amount, procedure cost and all these things are there. Now, here the critical column is this. So you can see here, if I scroll slightly to the right, see, this is the description. Anesthesia for procedure on salivary gland with biopsy. Okay, and you see F, place of service is the hospital, and this is the amounts charged. Like that, for everything it is given. Anesthesia for electric shock treatment, anesthesia for procedure on eyelid, biopsy of external middle, eardrum. So you see the text here. From this, you have to create TF-IDF vectorizer. And we will use these words to predict the dependent variable here is average Medicare standardized amount, payment amount and standardized amount. How much amount is paid? You can either predict this or this. Allowed amount, submitted amount, allowed amount. What is the submitted amount? What is the allowed amount for that procedure? And what is the payment made for that procedure? And what is the average standardized amount? See, the procedure will get only $438, but submitted is $680. Even though the doctor has submitted $680 claim, the insurance company paid only $438. Allowed is that, and payment is also same. Allowed and payment will have this. So if you see here, allowed and payment, here also submitted is 1959, but allowed is 237. Payment made is only 187. $50 they have removed. And standardized amount is 186. Standardized means all different various procedures. What was the standardized amount? So you can predict anything. This becomes a regression problem. You use the dependent variables, which are your words, TF, IDF, to do a regression model. Using sentiment, it becomes a classification model. Here it becomes a regression model. This is real-time data. You can use it in your GitHub. This is a very, very interesting data, and it's a very large data also. 2,73,212. You can run TF-IDF vectorizer on column E, create a matrix of words, and then use it as your independent variable to predict the procedure allowed and cost amount. Interesting case, right? You can see what is the predicted amount. So then what you can do, see here, injection, annual business visit, counseling visit, colorectal cancer screening, administration of pneumococcal vaccine. So different descriptions and procedures are. So you have to create a large scale matrix that covers most of these procedures. And then we use that thing to predict the what we call here the what sentences are 2,73,000. So you can have 300, 400, 500 features also, no doubt of right. So you can build a very big model. So you understood, right? This is your medical data. Similarly, if you are looking at e-commerce data, instead of this, what you will have? In e-commerce data, here what you will have? Reviews will be there. Reviews will be shorter sentences, right? Some people write it in 3 sentences, 4 sentences. So in e-commerce data, this will be reviews. In movies data, again, this will be reviews. It can be reviews and also plot, movie story also, short description will be there. And based on that, you can predict whether it is a hit or flop. So you have got the understanding how we use these NLP techniques in ML. NLP is a very large for medical diagnostics and all medical healthcare data. It's a very big process. We will work on this data. We will work on this data. This is absolutely real-time data given by the US government. We downloaded it from the US site only. And the PJ20 guys have worked on this data very detailedly, very things. And I think 2 or 3 recruiters amounts you have to predict. Sentiment. Sentiment is what? Pardon? Kiska? Here we are taking a real-time data, na? We are creating a real-time data. It's not secondary data. आपको data description कब मिलेगा? When it is a secondary data collected by somebody else and given it. Like in Medicare, we have the data description. Zero, wo kya hai, F kya hai, procedures kya hai, we have that thing there. But in case of COVID-19, we are creating a primary data, right? We are creating a data in our COVID-19 example. So that is how it works. When we work on that medium thing, that Medicare thing, you will also see the amount of analysis you can do. That you can also submit as your capstone project also. You can submit it as your capstone project also. If you do all sort of models, pre-processing, everything you do it, you'll get a good capstone project on real-time data sets. And you can put it in your resume also. You can tell the recruiter, I have downloaded the data directly from the US website and we worked on. This is not fake data. This is absolutely real-time data. So we'll work on this NLP based predictions. So we have to create independent variables where we'll create from the text or sentences. And then we will use that created independent variables to predict. We can do classification prediction if it is sentiment analysis, positive, negative, and neutral. We can also do regression prediction if you have a numerical value. Here, procedure cost is there. In movies, what we will have? Ratings. 1 to 10 ratings will be there. IMDb, 8.5, 9. We can predict the rating. What? Guys, we'll take a break. 15 minutes. Okay. We will build a logistic regression model. Okay. So shall we make max features 19 so that we can use the maximum available things? Max features will make 19, 950 observations. Minimum rows we have, right? 30 rows extra. So we'll make 980. Y is equal to sentences df dot sentiment. X is equal to x underscore tf idf. Y is equal to sentiment df. We have how many sentiments? 3 sentiments. Positive, negative, and neutral. From sklearn dot preprocessing, import label encoder. Why do we need to do label encoder? Because Y is in the form of text. Y is in the form of text, positive, negative, and neutral. So we have to label encode the things. Label encoder dot fit underscore transform of Y. We are label encoding Y. X is all numbers. We don't have any problem with X. The problem is with Y. Y is in text. Positive, negative, neutral. You have to label encode Y. So we have done the label encoding. Now from sklearn dot linear underscore model, import logistic regression. Logit is equal to logistic regression. Multi-class is equal to multinomial, because our data has 3 levels. By default, it does binary. Binary means only 2 levels, but here we have 3: positive, negative, neutral. So we have to bring this argument, multi-class is equal to multinomial. Logit model is equal to logit dot fit x comma y. Logit model dot score x comma y. 75.30.
If I don't mention will throw error.
It will throw error. It should throw error. Try, I think it should show error. It's taking, I think by default it is taking it. But it is always better to specify, right? Maybe the default option is multinomial only. So logit predict is equal to logit model dot predict of x. From scalar dot matrix, import classification report. Print classification report y comma logic predict. Why we got like this? ed dot cluster y comma logic predict. Oh. Hey, zero, why it is not predicting zero? Okay, we have zero, all three are there. It is not predicting zero. Undefined metric warning. So let's try decision tree. Well, decision tree also does the same thing. Yeah, logistic regression, it is not able to predict the values correctly. There is an error which is coming. See here, the cross tabulation zero is not being predicted. So logistic regression, it's not able to predict. No, I don't know. It should predict actually. If I don't give this, still it is not predicting. Whereas decision tree is predicting properly, print classification report y comma repredict. Yeah. 78% accuracy is what decision tree model is predicting it. The logistic regression is not able to do it.
So it is predicting neutral and positive. Not negative.
Yeah, that's what there is some error there. But decision tree is giving us better. Okay, done. You come from Kotura.
Yeah.
Kotur, because I used to come to Symbiosis campus. Mamidipalli, na? That Pitti laminations. That road, it goes inside, na? Mamidipalli village. And I used to also go to Jachcherla for Narsimhanji University. This time Narsimhanji, I'm taking classes for undergraduates in Tarnaka only. Otherwise, I used to come to Jachcherla. Highway only, na? You can get 80 and all. 1.5 hours. Jachcherla, pharmacy. Yadnagar, I came 2015 to 18, almost daily I used to come. Mamidipalli, Symbiosis. Maybe, I think October, no, November, December semester, I will take classes. Then I will come there. Yadnagar. Term 3 means December, I think it will start. Your placements will start as soon as I say you are ready. When I say you are ready, for that me to say ready, you should have your GitHub profiles ready. And you have to complete your second mocks. Second mocks have to be done in next 2 weeks. A test and mocks. No. Completion will be sometime in September or September 1st week or 2nd week, something like that. After that also you'll have Hadoop, Tableau, all those things will be there. Python will, we had to do Python deep learning, then Python imbalanced data, regularizations, all those things have to be done. Image, that is deep learning. Then we have to do big data, Python plus Spark. That's what deep learning. I'll explain calculation and all. We will start next week. So PySpark is there, Python Apache Spark, big data. 1 to 1.5 months it will take. Because the high demand things are now. What is in high demand and high salary is now being started now. The concepts are now starting. High demand and high salary profiles. So you should be able to ready with your GitHub project. Right? Not theory. On your GitHub profile only, they will say open your GitHub or send us your GitHub link. They will ask you what you have done, why you have done this. Then they will ask you, you have implemented decision tree. Tell me about the decision tree theory. What problems you have faced in decision tree? Problems is overfitting. Then how do you solve that problem? Max step that you have to fix. Or do you know understand random forest? What is the difference between random forest and decision tree? Like this, they will ask you. So whatever you are putting in your GitHub profile, you should be able to explain to the client in simplistic words. If you can't, they will simply say you copied from somebody else and they will outrightly, interview will end in 10 minutes. If your interview goes to 30 to 45 minutes, that means your chances of recruitment is very, very. So they'll basically start with basic statistics, mean, median, mode, ask questions about sampling, random sampling. We are doing now random sampling. Then they will ask you some questions about SQL. We have to do SQL also. Because now I think most of you might have forwarded SQL. So we have to do SQL, MySQL. Two types of SQL I have to do. MySQL and PostgreSQL is also there. I have to do 3 sessions on MySQL, which is high in demand. In the market, they ask for MySQL and PostgreSQL, which is again for petabytes and terabytes of data, large scale data. That also we will work on the data, which the project will be, again, you'll put the same project in your GitHub profiles. Movies data or some real-time data we will take, we will do also the queries, all the joins, multi-queries, DML, DDLL, all the from mathematical functions, everything will be done. Statistical functions, statements, all those things will be done in MySQL. So we will go. These 2 months are very critical. So it must be offline classes only. Because your parallel placement also will start. NLP, if you can crack 8 to 10 lakhs also they'll give you. Because see, this is very critical. You want a small data, 980. Now I will show you how to download tweets. We can download 18,000 tweets. Then we have to clean them up. We have to process them. Then we have to build models. That Medicare file, 2 lakh rows we have. You have to clean up all those things, right? Their cleanup is less. Because there are no special characters. The only thing is you have to do a TF-IDF vectorizer. Then you have to build a model. That's a very interesting project, Medicare healthcare analytics. So we will do all those things. We'll go one by one. But basic projects in GitHubs are ready for your basic projects. Some basic projects like I told you, Kaggle, or you are doing loan prediction. Some base project also has to be there. Sometimes they're asking, okay, show me the base projects which you have done. Some recruiters are also asking for basic projects. Like what you're doing now, loan prediction, what you're doing there and all. That comes under basic projects. Yeah, same thing, machine learning model. No, here the thing is the analysis will be different, sentiment analysis and all. So there you're doing only 2 predictions. Here you're doing multinomial, 3. And in case of that Medicare data, that's a real-time data. That's a real data. It's a purely real data, working on real-time data and then facing this, you're building a model with all these things. That's a big challenge. And that to 2 lakh rows, imagine. Some of your 4 GB RAM guys, you have to straightly start from Google Colab only. On your basic laptops, it will crash. That's what happened there. 2,73,000 rows means it's very large data, right? You have to start with Google Colab only. 8 GB RAM is minimum. That's to be on safe side. Okay, decision tree we built, right? The classifier. Tree predict. See how many, I have changed the max features to 19, right? Did you change it? Otherwise, same, we can, you build a model with max features 15. I have built with 19, that's all. That's not a problem. Online guys, you are able to do it? You all have Twitter accounts? Twitter. So this is one type of data, web scraping, and then you get the data and clean up and do it.
So it has one data set for prediction.
Which one? No, we'll download live data from Twitter. You're saying what? Wait. Job, that's a very old data set, job prediction. See, there are many data sets. IMDb movie reviews is the biggest data set. If you want to work on NLP data, that IMDb movie reviews is a huge data. IMDb, there are different data sets. One, a small data set, 1 lakh or 2 lakh. There's a 20 million data set also, IMDb movie lens. For that, you need to have 16 GB or you have to have Google Colab only. It can't run. It will run on Mac. Mac may run karega because it also includes CPU and GPU. It nikal ho jayega usme. There is another data called newspaper analytics data. Newspaper articles data set is also there. These are old data. These are textbook old data sets which are there. Google newspaper data sets are there. NLP data sets, a lot of them are there. But if you want to download the data, see, this is spar matrix, na? Sparse matrix को आप scaling कैसे कर सकते हो? Which one? हाँ, लोन प्रेडिक्शन में आप देखो न्यूमेरिकल डेटा में करना पड़ेगा शायद 3-4 कॉलम रहेंगे ना, because in loan prediction also most of the data is categorical. 2-3 columns only are there. There you have to do standard scaling. But उसमें क्या, even if you do that also, it's very less. The R square, sorry, accuracy. In loan prediction आप करके बाद आप score डालोगे. Accuracy आएगा. If accuracy is increasing, then do scaling. If accuracy is not changing, don't do scaling. That's what, no? It will not. 95% of the times, it doesn't affect. Scaling हम इसलिए करते हैं to reduce the computational intensity. Not, see, computational, अगर आपका CPU small है, बड़े numbers रहेंगे, लाखों में numbers रहेंगे, तो calculation intensity हो जाएगा ना, millions में, billions में चला जाएगा. उसको आप decimals में कर दोगे तो it will hardly go to 10s and 20s. That is the purpose of scaling. Like आप image processing लोगे 0 to 255. Pixels का क्या value रहता है? 0 से 255, right? The pixels are between 0 to 255. So, and then you square them again and again, 255 to 255 into 255, it goes into some lakhs and millions of data, that it gives problem. It becomes a very large number, and उस large number का process करने में CPU time लेगा. अगर उसको normalize कर दोगे 0 to 1, 0.4 to 0.4, 0.4 करो तो कितना रहेगा? Value तो बढ़ेगा नहीं ना? So the reason why we scale is to reduce the computational intensity. Second is to remove bias. Textbook में क्या बोलता है कि larger numbers को bias दिया जाता है, छोटे numbers को bias, low bias दिया जाता है for smaller data sets. But when you are dealing with large scale data, that bias also does not have an effect. It is purely computational reasons only. और आपका loan prediction तो बहुत छोटा data है. You can decide by accuracy. apps.twitter.com. See, once you go to apps.twitter.com, you can create a developer app. You need to have your mobile verified Twitter account. So I have this, you need these keys and tokens. To access the Twitter server, we generate API key. Okay. So we need this API key. Keys, we need them. So let us see data is text mining. Because we have TWP in Python. Python may be module high. We have something called TWP in Python. So what happens in Python is the TWP will not allow you to download more tweets. Whereas in R, we have this what you call oh, yeah, please. Yeah. Where is the stock data? List. Yeah. So what we have to do is you have to install a package called rtweet. So in Twitter, once you create the developer account, you will get access. You have to create an application. For that, you are answer a questionnaire. They'll ask you a lot of questions. What is the purpose? Why do you want to do? You tell that it is for learning purposes and academic only. Once you have done that, if you answered everything correctly, within 3 hours, you'll get the approval for the app. Once you get the app, you have to go to keys and tokens, where we need the API key, API secret, access token, and access secret. 3 things are required. One is API key. API key is required. So which is there here. I have regenerated the API keys now. See here, this is the API key. Copy, paste it in double quotes. API secret key is equal to double quotes. If you go there, if you scroll down, you will get the API secret key also. Right? You save them here. Then once you say yes, I saved them, you have to generate access token and access secret. Access token and access secret. So After API keys, you have to create access token is equal to, if you go to this side, copy the access token, then access token secret is equal to double quotes. You'll get the access token secret also, copy it and paste it here. So API secret key, access token, access secret key. Now we need to create a access token. KRP research. App name is KRP research. Is that correct? Just let me check the app name. App name KRP research. Okay. Okay. So shall we search tweets on climate change? Okay. Hashtag climate change. So I'm downloading 18,000 tweets. 18,000 tweets will be downloaded for the thing called climate change. Hashtag climate change is the thing which we are going to use. Once you get the data, I'll send it to you. You can import it as a CSV file. It will give you some 80 columns of data. 80 columns of data means user ID, location, time, retweet count, like count, favorite count, number of words in the tweet, number of characters in the tweet. Oh, lot of data is given for one tweet. And all this data we use. We can all actually, because of privacy, we are not getting it. Earlier, we used to know the gender also, male or female. We used to know the location. We will convert it into data frame. No. First, I am downloading the data now from the Twitter server directly. So I have access using the secret keys and tokens. I have access to the Twitter server. I have access to the Twitter servers. In that, I am accessing a public handle called hashtag climate change. Because a lot of floods and all are happening. Right? COVID data, we already worked on COVID data. So for a change, we will work on climate change data. So hashtag climate change is a public handle. So we are down to third. Whatever tweets in the last 30 days, we will get them. 18,000 tweets we are asking it to give. If it has 18,000 tweets, it will give you that 18,000, or if it has less than 18,000, as many are there, it will give you that many tweets. So this is how we can download from tweets. Earlier, we can do such things from Facebook, but they have now, Facebook guys have blocked it completely. Even your own Facebook updates, you can't download. There are a lot of questions they're asking. The only thing which is now freely accessible is Twitter or public websites where you can scrape it and get the content. So we are downloading live data of tweets. You can download from public handles which are active. Otherwise, you'll get only 1,000 tweets or 200 tweets like that if the handle is not active. If the handle is a very active handle, then you will get a lot of data. So it has already completed. Let us see how many we will get. In tweet, the cleanup process is even more high. So if you want to do the same thing in Python, we have to install a library called tweepy. Now, but the tweepy problem is it gives you less amount of tweets. Not unlike R tweet, which gives you 18,000 tweets, tweepy will give you less number of tweets. But tweepy, we use it for streaming. Streaming means live tweets, right? Live client and live tweets. For streaming client, tweepy is better. You can use tweepy streaming client and you can give the bearer token here for my app. And then you have to give the rule and all, and then it will start getting the live streaming tweets. So tweepy has an advantage in terms of streaming tweets. But if you are looking at large scale tweets, R is the best platform. Right, it is taking time to save. So tweepy is a library within Python for accessing Twitter. For using, you can use streaming related data. What models they're offering. No, these are different ones. Yeah. So see here, we got 17,974 observations of 43 variables. We got 17,974. This is the tweet text. See, full text. See, climate change related text. See, you get the display text range, entities, metadata, source, whether it is mobile or tab, iPhone, all those things will be there. This is your text, display width. NS will also be there. Some data will not be given. Because what happens is some data, people, you know, the GDPR rules, privacy rules in Europe, data privacy rules are now very strict. You can't have data of clients without their permission. So that is where the problem is now. So now we will save it as climate change dot CSV. Oh, save as CSV also they have changed. A lot of changes happen in R tweet. I have to work on the model again. Oh, it is not changing. Didn't save. Okay, write as CSV. No, it's not able to write it, right? It's not able to write it.